My name is Steve Lerner. I am the director of sales engineering for a new, hot California startup called Product Science. And we're going to talk a bit today about mobile application performance done the right way. And the right way is to be able to see your app. See your app. And we're going to talk about what that means. I still have to get a picture of you guys crowding in here. It's like the Beatles of performance engineering today. So before I do any kind of talk, because I've sat through a lot of these talks, I like to make sure that the person who's speaking is credible. So I'm going to spend a few seconds about me. I've been a performance engineer my entire career. And it started actually with streaming video back in the day, where I built and designed and patented the systems that are used to deliver all streaming media. Everything you watch on Netflix comes from a certain pattern, and that was developed about 22 years ago. For 5 years, I was eBay's lead and main and only performance engineer, from the mobile apps up to the edge of the network. And that was a pretty substantial job. But eBay is a big company, and I really wanted to get back to working with customers at a startup. So I joined a startup called Signal Effects, which was acquired by Splunk for $1 billion. That was my unicorn. And while there, some friends of mine at a startup said, hey, we're going to be building performance engineering tools for mobile apps, because nobody really does it at the level of what they do for servers, and we'll talk about that. And I left Splunk, and I joined Product Science, and that's where I am today. I'm going to get one more picture now that the room is really packed. Everybody wave. Give me a wave. Woo-hoo! I love it. Okay. So why should we even care about mobile app performance? And it's because of developers, and it's because of the technology involved. So what I notice about mobile phones, because the truth is I'm not a mobile app developer. I'm an engineer of all kinds. But when I got onto the world of phones, I noticed that a phone looks a lot like a cloud. It looks a lot like AWS. It's segmented into different kinds of hardware. There's different kinds of libraries. There's different kinds of frameworks. There's different kinds of performance happening in different parts of the phone. It looks a lot like cloud. And what's built in to measure the performance of a mobile phone is not like anything we have for the cloud. It's basically random system traces and noise and chaos. And what happens is people build mobile apps, they launch them out into the world, and then if there are problems, it's the DevOps teams that catch them, and they get to order the pizza. So you're sitting working on the app, and you send it out into the world, and then there's a problem, and the DevOps teams, they're like superheroes catching all the problems in the apps. And that doesn't make any sense to me. Why don't we solve those problems before the app goes out into production? Why aren't there any tools that can do that? And so to do performance right, we need to do it with tools that are proper. I call them proper tools, and they weren't previously available for mobile apps until today. And by the way, this is true for iOS. Everything I'm going to talk about is true for iOS as well. So when it comes to tools for mobile app developers, I like to talk about some of the theory behind it, which is that the server teams, the DevOps teams, they have really cool tools. They can visualize a transaction on different servers, on different containers, Kubernetes containers, and different Amazon virtual machines. They have all these great visualization tools. But what do we have? The Android guide to how to use Profiler on YouTube is from 2017. And the documentation for Xcode's instruments is from 2019. The tools that are available are basically legacy tools. There's nothing that's modern. And the way that troubleshooting happens on mobile apps is you're basically regressing through static traces. You're doing static snapshots of the app running, and then you're looking at its traces and hoping you'll find something and looking backwards. But this is not a modern way to look at performance. There are new tools that do APM, application performance measurement, that have finally arrived that let you see your app. See your app. Not dive through logs, not dive through random sets of traces, but to see your app and see your performance. So let's first talk about what is performance done wrong. So if you cannot see your app and its correlation to your code, you're doing it wrong. How do you know what's really going on in your app if you can't see the app while you're looking at the code and the performance? And the legacy tools, you wind up having to do manual instrumentation, right? How many people here have added breakpoints into your app code and ran it and then looked at logs, right? Okay, right? That's wrong, because that's not how your app's going to run in production. You're not studying a user flow. You're doing things like we used to program in BASIC on an Apple II in 1981. Okay? When you're doing things wrong, you can't see causality. You can't see why something's happening. You're looking at what's happening. What is the speed of this function? But what about why? Why did it slow down? What is the speed of this user flow? But how about why, right? Causality. And if you're doing lots of building and digging and breakpoints, and you make a fix, but you don't know if that fix is going to work forever, if it's just working now, this is performance done wrong. And I have this illustration here of what I call unhelpfulprofiler.com. This is what all the built-in profiling tools and what most of the vendors look like, is they show a function and a length of time, and this is done wrong. You can't see your app. You're looking at something that's abstracted. Okay, so how many people here have used tracing and a profiler for your mobile apps? Anybody? Okay, who has never traced your app? Okay, be honest, because 95% of mobile app developers I talk to have never traced an app. Okay, so I know, okay, you guys are shy, it's all right. So how do you do it right? What's performance done right? This is a lightning talk, so they want me to go fast. I'm sorry if it's super fast. Come see us at the booth, product science booth here, and we'll go a lot slower. Even better, let me give you a full demo after the show. To do it right, you want to see the app alongside the code and see it running. And you want to break down your app into user flows. So what is a user flow? An action and a reaction. I click a button and something happens. I slide something and something happens. That's what a phone is made out of. Actions, user flows. A click and a reaction. A slide and a reaction. Put something in a cart and the cart shows. You need to break down your study into these user flows because these chain together and create the whole experience of the app. Performance done right means you're fixing the problems before the DevOps people tell you that they're broken. I can't believe this if there's a whole, and I came from Splunk where we were selling to DevOps people all the time, real user metrics, right? The phones are sending user metrics and the DevOps teams are hunting down developers to find problems. That's backwards. Why are these problems fixed in advance? Why are the apps going out into the world slow? Okay. Also, if you're doing things right, you should not require any manual code changes. You should not touch your code. You should be able to observe your app, see your app, and see how it works without any code manipulation. You should not have to change your app to see it. And most importantly, when you're doing things right, you're understanding why problems are happening. Not just that they're happening, but why. So let's go through an illustration here of doing things right. And I have a demo application, and this application has a problem. The problem is when you click the next button, there's a 1 second lag. Okay, and to fix it, we're going to use video, right? We're going to see the app in order to fix it. So here's what it looks like. We click the next button, and there's a lag, right? When we click previous, it jumps back. We click next, lag, previous, okay? So the next button has a lag, right? How many people have done something to an app, and you're clicking on it, and it's lagging and lagging, right? This is a common problem, the most common problem. So the first thing, when we want to analyze this is think about the code that's behind it. Okay, so here's the code that's behind this button. Let's see, it appears, yes, my mouse appears. So basically, someone is trying to do parallelization. They're trying to make this app performant, and they're using a Kotlin thread. And they're dispatching some work. My work is simulated by a thread sleep. This could be a network request. It could be prefetching images. It could be some other kind of transaction. I'm simulating it here. And then they're activating the button action here. And they're doing it with what they think is the correct thing to do, right? They're using a thread dispatch, but it's not seeming to work. There's this lag. Okay, so now let's look at what it means to see the app. So if you want to do performance right and see your app, you want to see the app next to your tracing so that you can zoom in exactly where someone clicks the next button and correlate that problem with what's happening in code. Why would you do it any other way, right? Only now do we have a tool that can do this kind of thing, that allows you to see the app and correlate the two. I'm going to get one more picture because now it's like standing room only. It really is like the Beatles, and I don't get my paycheck unless I send this back. So I should say I don't get my commission. So let's dig a bit deeper. So what are we looking at here? What is this? So the first thing we're seeing is a multi-threaded tool, right? Where you have a main thread and you have dispatched and other threads here. The second thing you're seeing is something totally unique in the world, which is this yellow line that's showing which function calls which function. Why is it happening? What called what? Not just a big list of what's running, but what is being used. What is happening here between each function. So this one calls this, choreographer draws the frame, calls the fragment manager, and look at this. The fragment manager dispatches this work, but the work is in series. And even though it's going across multiple threads, it's blocking the main thread. Now, to your eyes, this looks like it makes perfect sense, right? I can see a video here. There's the click on the next button. I see exactly where that's happening on the timeline. I see the lag that's formed. I see that the functions are jumping across threads, but it's blocked. Yeah, of course it makes sense. But this is the only tool in the world that can do it. This is new technology. It's from California, where we invented Disneyland and Fender guitars and Vans shoes and Google and the iPhone, right? This is new tech. This is brand new. This is the way to do things right. This is what the DevOps teams have for their servers, the ones that call you and then get to order food and expense it. We're going to expense things now because we're going to solve these problems before they get into production and not give the DevOps teams the glory. I'm so tired of the DevOps people. I like mobile app developers better now. I'm sorry. You know, I'm on this side of the fence now, right? So let's get a visual of this in action, okay? So we're going to drag the play bar over across the execution of the user flow, and there's the click, right? And then we're going to scrub like Adobe Premiere, right? We're going to scrub in on where that delay is and zoom in and see the code that's executing and see how it's coming off that thread with a delay. Right, look at this. Imagine being able to study your app and see your app, right? And we can see here where it comes off of the main thread, goes into the dispatch thread. Amazing. This is performance done right, where you can see the app and see the code and see what's executing as a user would do it from a phone and be able to research and understand your problem and fix it. So let's fix it, right? It's a lot of talk, right? But can we fix it? So we can fix it because we now see what's being executed. The fragment manager is going off thread. And why is it going off thread? Well, it was in the wrong spot by one curly brace, right? The button action was being dispatched along with the work, and that's what was blocking the app. We were one curly brace off from it being correct. How many of us have screwed up something by one curly brace and spent days looking for it, whereas you could have spent seconds? Now the tools exist to spend seconds. So, does it work? Did we fix it? Let's check it out. Next, previous, no lag. I hit next, immediately jumps. It's fixed. So let's do a search. I'm going to run it one more time, make sure everybody can see it. There's no more lag. So what do we see now? So now here again, let's take a look. We've got the main thread, the dispatch thread, and look at this. The buttons are clicking, but the dispatched work is in parallel. There's no yellow line. This is new, this concept of seeing functions connected to each other that execute a user flow. There's no yellow line jumping off into a different thread, blocking the app. This is how a server person would do it. Now we can do it in the mobile app world. This is performance done right. So let's check out a video of investigating it, right? So yet again, we drag the playhead over, right? We scrub out where the problem is, zoom in to look at the code that's executing. We can see the circling is that the work is dispatched correctly in parallel. So we can zoom in, examine the fragment manager from our code, and know that everything happened correctly. And I'm doing pretty good with time. It's a lightning talk. We're moving at lightning speed. This is a flag. So if you want to share work with people and make markers of things to look at, you should be able to identify problems and put down flags of where things are happening so you can do research later. And this is what performance looks like done right. So let's scoot over to the next slide. Okay, so to summarize in this lightning talk, because I want to leave time for questions for this sold out room with standing room only, performance done right means see your app. see your app. If you're solving for performance, you should be able to look at it and see what the problem is and zoom in onto the code and identify the threads, the thread behavior, the functions and the methods that are happening, and have the noise filtered out and see which functions are calling which. This is performance done right? So we want to use a video and visual correlation to link performance to code. That's the first thing that's important. Avoid manual instrumentation. If you are changing your code to study it, that's problematic, right? Your build environment should generate a study build that does all of this for you. You should break down your study into user flows. Don't do things that are 1 minute long. Okay? Each part of your app chains together, action, reaction. Break it down, study, and solve for it. And don't look at a static analysis of the site, of the app or the page on the app, because this isn't showing you why something happened. In the end, what's most important for doing things the right way is to develop for performance, right? As you build, study your changes. If something does get reported to you, study it as it looks to the user, and please don't let DevOps have the last laugh and all the pizza and all the sushi, right? They shouldn't be getting that. They should be fast asleep because everything works. So this was a lightning talk. It's supposed to go fast. I left 4 minutes for questions. Let's have it. Questions. I'm going to start pointing at people randomly to ask questions if you guys don't come up with questions. So if you don't want to get pointed at. All right here with the cool hair and the cool shirt. Someone repeat it, or is there a microphone, Sheldon? No? All right, come up here and tell me, or yell it out. So first of all, he asked about an emulator and he asked about expense. Okay, so this is designed to be used today on phones because we don't feel that emulators are correctly representing the performance of phones. Also, phones sort of go down to a certain level and a certain behavior. In the future, we are working so that there can be unit tests done in CI with sort of an emulated test that can take a look. But still, in the end, you want to know how it looks on a phone. And in terms of expense, that's a great question. So we find that it takes hundreds of hours to solve simple problems. And if you multiply hundreds of hours of digging by hours of people time, if you can save hundreds of hours a month per person dealing with these kinds of problems, you're saving multiple people worth of salary. And this kind of thing costs a fraction of that. So the way that we have tools to analyze labor cost savings and things like that, but when we look at the way people develop for mobile, they are stuck in things that are everything but development. They're looking at manual breakpoints, manual instrumentation, digging through logs, digging through noisy traces, rather than studying a user flow and solving a problem. So it's actually a cost savings. It's not an expense. You're saving money and people and time by using more efficient tools. In terms of performance, well, I'm glad I answered that one. This does not make any difference in the performance of the app. This instrumentation, yeah, because it's using the same system tracing that's already there. So the system tracing is built onto the Android. It's already enabled. So this is just riding on top of that and adding more useful information. So this does not impact the performance of the app. Note that this does not go into production. This is a pre-production tool. This is for studying while you're developing. This does not get included in production at all, right? This is for as you're developing to study performance, because in production, you shouldn't have any overhead in your code, right? It's pre-production only. So, and it does not impact the app's performance because it's riding on top of stuff that's already there. Does the build take longer, is what you're asking. The build does not take any longer. The instrumentation does not impact the build. Again, it's California technology. If you like Disneyland, Fender guitars, and skateboards in Google and iPhones, this is from the same place. I'm not sure I'm hearing everything. Come up to me after. Let me drill down with you, okay? Because I want to give some other people a chance to know. All right, red shirt over there.
How do you see this going to sync with something like macro benchmark?
I don't know macro benchmark, but it's a Gradle plugin to do this, right? So, it should coexist with anything. It shouldn't matter because this is impacting how the traces are written. The tracing system is built into Android. So all it's doing is adding in decorating information that didn't exist before into tracing, and we have a sophisticated tool that does the magic and the analysis that connects all the functions together. So it shouldn't be impacted by other libraries or anything else that's in there.
So macro benchmarks, Google's automation for iteratively rerunning the same benchmark?
I haven't studied it. Let's talk about it later. There's millions of different tools out there. I'm not going to know them all, but I haven't. Nothing I've heard has ever been impacted. We've got every kind of customer from big to small, finance companies to startups. There's been no impact from anything else that's out there, and it's not a competitor to anything else out there either, because nothing else uses video to analyze an app. So they told me it's 20 minutes, right, Sheldon? All right, 20 minutes. Okay, so it's supposed to be a lightning talk, right? So you're shutting me down, right? They're saying yes, I'm shut down. So product science is the booth, right? Come talk to us, come try it out. And there's anybody who goes for a full demo and a full trial, we got 1 month for free available. So come check us out. We're down facing that far side of the building. Thank you very, very much. And come bring me questions here too.